Okay, so what we've got here is, first off, thankfully Emily and Danny went through and gave us some data, so hopefully we can see this. We've got a time value and volumes. So one of the things I want to address first off would be the time values. So one of the shortcuts we can get through and do is we can have Excel do a bunch of calculations for us. One of those calculations, believe it or not, has actually already happened here. So when you go to enter your times, you can literally go through and enter each number in. However, you probably picked very set intervals. In their case, they went through and did the first 10 data points every 15 seconds, which means you see every 15 seconds a new number. So what we can go through and do is go into Excel, and if you look all the way up at the top, I'll try and, it's going to be interesting going back and forth. If we click to that new cell where the 15 is, and if you look up at the top of Excel, there's an equation bar. See that equation bar? You notice that does not say just 15. It says D5 plus 15. What is D5? The cell right above, which is where we put the 0. So what we're telling Excel to do is run a calculation. Use D5 as my first number and add 15 to it. Okay? On its own, that's not a big deal, okay? Because that just gives us 15. That seemed like an awful lot more work than just entering 15. But what we can now do is click on that cell, and if you go to the lower right-hand corner, okay? I don't know how easy it is to see this, and I'm not seeing a cursor. Oh, I'm not seeing a cursor on the screen. Go to the lower right-hand corner of that cell, and you should see your cursor turn into a black T. You guys see that T, at least for you guys here, okay, versus the white T. We go to that corner and now click and drag. It will copy that calculation across. So let's go through and delete some of these. We went up to what, 135. So I'm going to clear all of that data. Why did all those numbers change? That makes me nervous. Click and drag. There we go. Were those 8.7s all the way through?
Yeah, it stayed.
Oh, okay. Well, then never mind. It's fine. So the click and drag, it does the calculation repetitively for each of those sequencing downwards. And now I've got all those numbers in there very, very quickly. And I didn't have to enter each number. This is something that will become increasingly important with the larger calculations, which you'll start on probably Monday or Wednesday of next week. When we do the rate law experiment, you're going to want to use Excel to do all your calculations for you, because you'll have to run the calculations 8 or 9 times, the exact same thing. Okay, so you'll want Excel to do all the complicated stuff. Okay. In this case, we didn't click and drag any further because 165 was when she started the reaction, so that was 30 seconds later. So if I want to change the formula now, I'll change it to, if we take a look back up at the top again, in this case it's D14, so the previous cell plus 30. Okay, same idea. I can now click and drag that lower right-hand corner and do that, for instance, just to be obnoxious, forever. Okay, and it's now added 30 in each of those cases to the previous cell. Okay, so that can be a bit helpful in the process in going through and attempting things. Oh, that could be my job offer. The next thing you'll want to go through and do is put in all your volume values. There's no shortcut there, you just got to do it. Okay? So the more important part, or what you guys are probably more interested in, is getting into the charts. So what we'll now do is go into charts. Since we're using Microsoft Office on a Mac, the formatting may look a little bit different. The chart that you want to use is going to be known as a scattered plot. I typically do the straight line connected scattered plots. Sometimes, if I'm really picky about it, I'll jump to just the scatter plots. Do not use the line. Okay. The problem with that is it defines your x-axis as one interval unit. So when you go through to plot, it's going to set your x-axis as 1, 2, 3, 4, 5, whatever. Sometimes it can be a bit misleading, and you can enter in, it'll show you different numbers. Those numbers may say 165, 195, etc. but they're only counting it as one unit. You've just changed the name of that one unit to now 165 versus 195. Why is that important? If your x values vary the distances between them, and the line plot, it does not vary. You get the exact same distance between them. Okay, kind of makes sense? So, with this case, I want, going under, I'll do the straight line marked. Well, that's a bit interesting. I'm going to delete all that actually. Let me just do that delete, yeah. Usually I have it open up into a blank page because I want to make sure that Excel is putting in the data correctly. Okay, so you'll probably, if I do it, you'll get a blank thing like this. Right click and you'll go to select data. Okay, at this point there's no data on that graph, so you should see something with no data there. So what I can click is go to my series, which is how many different things are you going to plot. And we'll click add data. Okay. In this case, for this experiment, I just want to see everything at first. So I'm going to call this everything. If I can spell. Everything. Come on. X values. What do I want to plot on the x-axis? Time. So now what I'll do is get that, make sure that it's highlighted, I guess, in the x value section. You can click the right, that little button there, closes it, and now it's saying select data source. The x values, I want all of the time values that I have data for. Okay, so in that case up to 765. The y values, same idea. Usually you have to delete that bracket 1. I still don't know why it does that. We'll go through and do the same kind of thing. You don't have to select top to bottom. You can go bottom to top as well. It will do it correctly. We hit enter, and it's now put in all of our data. Okay, and it's got it set. See, did it actually show it? It does actually show it. Okay. So at this point, I would go ahead and click OK and close it. When we look at that data, anybody notice any issues with that? What was our line supposed to look like? We were supposed to see flat, drop, flat. That really just looks like flat and a giant peak. Okay? More than likely what happened is that data point is wrong. Yeah, so that says at time 495 your volume was 785. So what we can do is go to that value and say that was actually probably 7.85. Okay, and hit return. As soon as we fix the data, it actually plots it more appropriately. Okay. Another thing that's going to be important to mention here, you've got your volume measurements as 8.81, 8 something, etc. Is that what everybody has? No. What do you guys have?
For what?
For your volumes, what's your start volume?
8.85 milliliters.
Anybody else?
0.88.
It's 0.8. This is one of the big reasons we use leading zeros. If you take a closer look at those pipettes, there is a decimal point before all of those numbers. Okay. It's not going to change any of the fits necessarily, but it is going to change your change in mass, or change in volume, because you're now saying milliliters when really it's not milliliters. It's a fraction of a milliliter. So we should change all those numbers, shift that decimal point over. You'll still get the same number, but to the wrong power, I guess. Okay, so you'll be off by a factor of 10. Okay, so make sure you're aware of that. Make sure when you enter your numbers that you're looking at 0.8, 0.7, all of those. Okay, just to clarify. We don't need to know that yet, or at least to do the rest of this. Okay, so that doesn't have to be perfect. So there's the data. Not the nicest looking, but we'll work with it. What we want to go through and do is get Excel to give us straight lines for the beginning of the reaction and the end of the reaction. So one of the things that Excel can do is fit a trend line to this. So we can click on the data, and if you're writing out directions, you might want to pause for a moment here. If we click Add Trend Line, we'll open up with a new window. We want it to be linear. We can tell Excel, hey, I want that equation displayed on the chart, and we can click OK. What did it fit the straight line to? The whole data set. We only want for the beginning data set. Okay? I cannot find out how to get Excel to only fit portions of an entire data set. So the irritating thing with Excel is that we're going to have to go through and adjust this. So I'm going to delete that equation. And now instead of plotting the whole thing, I'm going to change my plot a little bit. I'm going to add a new series to this. It's irritating that it does that too. This new series I will call the beginning of the reaction. Okay. I didn't like your 0 value, so I'm going to say the x value was 15. Why did it do that? Where was our flat line? About 165. So we'll say 15 to 165. Come on, click, drag, 165. Those are all my x values. For my y values, I want that same 15 to 165. Okay? If we go back to the data set, you'll notice we have those data points now as a different color, because Excel will do that for us, showing those lines, or that data. To me, all of those look like they're roughly in a straight line. That's fine. I'll add a new data set, which is going to be pretty meaningless, but we'll do it anyway, and I'll call it reaction, okay, or RxN for the reaction actually occurring. The x values for this are going to be 195 to wherever I've decided, oh man, let me delete that data set for a moment, to wherever the reaction is ended. Okay, that ending point is pretty much arbitrary for us. So what we're going to do is take a look at this data set and decide where do we think the reaction ended. Okay, right about 400, I agree. So what we're going to say, we'll put the cursor over that data point and it'll tell us the data point. Okay, so the middle of my reaction, or where the reaction's occurring, is going to be from 106 seconds to 405 seconds.
I'm going to close everything up so they will believe me when I report it again as being hot.
Okay, that works.
It's pretty good. It was comfortable today, wasn't it?
Yeah, it wasn't bad.
But that's just because I opened up the doors before you got in there.
Thank you.
It was bad before you came in.
Thank you.
Equals, so we said 165 to, I already forgot, 405? Yeah. Okay. If we move this out of the way, you can see it's now highlighted that next data set all in green. Okay, so we can see that that's been identified as a separate thing. The last thing we'll add on here, change the name of it to the end of the reaction, our x values. I want to include 405. I won't include 405. I'll do 435 up to the end of the reaction. Y values, 435 across. Any questions about anything we've covered so far? Kind of makes sense? Okay. You're probably lucky that you're watching this, because you can't see the cursor in the video. Sorry for those of you watching the video. Okay, so we now have our 3 sections of data. We want to have Excel go through and fit. So we can click on the data set. In this case, I wanted that beginning section just to make sure that you did it right. You should only see the data set for the beginning highlighted. Okay, so you see the purple and blue on the far right, that is left, I mean, on the far left, highlighting that data. Same idea as we did before, right click, add trend line. We want it to be linear, so the type is linear. Options, we want to see the equation. This next part, depending on the version you've got, isn't going to be as nice. Okay? It just so happens that using it on the Mac and the version that I've got, I want to see that line predict way out over the rest of the data so that I can then see it. Okay? So because, I guess Macs are nice, we want to forecast that line forward. So we can up the number of periods. And you'll notice we don't really see, oh, come on. See how our data point, our our line starts to extend outwards. You guys see that? Okay. Because that's going to take forever, let's just make it 1,000. There we go. Maybe 1,000 was too much. Let's try 500. 600. There we go, 600. Okay. So it's now predicted out so we can see that line. That'll help us kind of see things later on. You'll also notice it gives you the equation of the straight line. You now have that slope. You can calculate your y value. Okay. That y value, when using that equation, is your y or your volume initial for every one of your changes in volume. Okay, at that time. Make sense? Yes.
So we don't add the zero then, just take it out of our.
That depends on the data set. Okay. I decided to not include her 0 point because I see a substantial change in the volume there. So to me, what that is that when they added the sulfuric acid to their reaction, the sulfuric acid still had a little bit of heat to it, which caused the ice to melt right away. It then stabilized. Okay? It's up to you. If you see that it looks nice and it looks kind of smooth as a straight line and it's angled downwards, that's fine. If you don't see it, then don't worry about it. So look at, you kind of have to evaluate per data set to decide. Okay. The next part of this that we want for a straight line is the end of the data. So we'll go to the end of the data. Again, we should see that it gets selected. So in the lower left-hand corner, you can see that we're missing the big gap in between. Again, right-click, add trend line. It should automatically give you line options. We'll display the equation on the chart. If you want to see the line propagate back towards your 0, you can do that, except in this case, are we forecasting? Are we going forward or backwards? We're going backwards, so what we could do in this case is change the backward number. Let's try 400 and see what that does. Let's try 400. Or not. Why is it not doing it? That's weird. Why is it? Huh. Display equation. I don't know why it's not letting me go backwards. Oh well, there's not a lot I can do about that, so we just have to stick with what we got. Okay? We now have our two equations of the line to get our change in volume. Okay? If you look at if you guys remember before, we had the data set before where we picked our volumes and we said it was the distance between these 2 points. We did something along these lines, right? We talked about in recitation. Okay. To get that figured out, what we would do is pick the time at those for each of those 3 points. It's entirely up to you which 3 points you want to use. So in this first case, that looks like roughly, I don't know, 425. That is the x value. I would plug 425 into the equation of the straight line for my y final. I would do that 425 into the equation of my straight line for my initial. The difference between those gives me the change in volume at 425. I would then go through and repeat that calculation here, except now what's my time? 580, 590. We go through and run that exact same calculation, get a new change in volume. We do it again over here, except now our change in time, or our time is 7:30. Same idea. We get a new change in volume. Okay. When you look at the lab procedure or the lab handout, they show nice and neat, like drawn on, or not drawn on, computer-generated straight lines. You do not need to show those computer-generated straight lines. If you would like to, by all means, you can go ahead and do it. I'm fine with the hand-drawn stuff that I've got here. Okay. Ideally, when you show your calculations, you should specify that you've got, say, volume 1, volume 2, volume 3. So that I get an idea of where you're pulling that information from. Okay? Once you've got those changes in volume, you can then go through and do the rest of the calculations. Okay? Questions about that?
With the straight down lines, can we just draw those on?
So I guess I didn't finish that statement. You can computer generate them, or you can just hand draw them.
Oh.
Ideally, you get a ruler and draw it so it looks relatively straight, but I'm not going to care too much about that either, and you can attempt to draw a straight line but freehand. Okay. To do it in Excel, it is possible, or at least I saw it being possible earlier.
Can you just draw a line?
Oh. Fishing.
I saw it on a computer, on a PC. I don't see that option on mine. I can cheat. Actually, here we go. If we go to Insert, Shape, boom. Thought I couldn't do it, did you? There we go. Straight line. There it is. There's a fancy looking straight line to make me think that you calculated it. And we can even pull the Control Copy, Control Paste. And pick our second value. You'll notice the line is a different length, and that's because our two fit lines aren't perfectly parallel. They are slightly askew, which means your changes in volume will be different. And we can even throw up that last one just for the heck of it, right? There we go. Ta-da!
Do we do the calculations for all different changes, like the 3 different changes in volume?
Yes, you will need to do the 3 volume changes, propagate those to a heat term, a joule value. Once you have the joule value, you can average. But you have to get that joule value first.
Is it just to make sure we're kind of like on the same path, or why is it 3?
We're doing 3 volume changes to kind of average out any kind of mistakes. That's kind of the intent behind it. I don't want you to average the volumes because each of those volumes don't necessarily work with each other.
Just the heat value.
So you should propagate that data through until you get kind of the end result, which is ultimately your energy. I think if you average it there, you'll get a different answer than if you average these 3 volumes. And then run through to your heat term. Okay. Questions about that? Okay, so that should get you your volumes. Once you've got the volumes, you can go back and start plugging stuff into your equations, try and get stuff solved there. Okay. If you come up to me with a volume and want help, by all means, I'll go through and help you push all the way through. Officially, we've got office hours now. A pair of students stuck around after yesterday's class, and they got their energy terms within an hour. And that was them doing it ultimately by themselves, just playing with the stuff that I'd shown up in the class. Okay? And I just went through and checked their results at the end of that. Okay? So if you really sit and pester me enough, you can probably get it done faster than that. Okay? So, go ahead and call